Hi guys, today we're going to do day 2 with radicals. We're going to learn how to deal with radicals that have fractions in them or fractions that have radicals in them, either way. So let's begin. So I don't want you to do the do now. Oops. So here we go. So day 2, radicals with fractions. How to simplify radicals that involve products and quotients. Now, the division property of square roots says that if we have two numbers, a that is greater than 0 and b that is greater than 0, then we can, if you have a fraction inside a radical, then you can distribute the radical in a way and give the radical to the numerator and give the radical to the denominator. On the other hand, let's take a look. So we have the square root of 36 over 49. And you must recall that 36 and 49 are both perfect squares. So we put the radical to the numerator as well as to the denominator separately. And then radical 36 becomes 6 and radical 49 becomes 7. So let's try a few. We have radical of 64 over 49. So you're going to split the radical to the numerator and the denominator. And this one is fairly simple. It just becomes 8 over 7. There is no need to go any further. You can stop right there. No need to make it into a mixed number because I want to see if you know how to do the math. So here's the next one. This one is slightly little bit more tricky because neither 8 nor 50 are perfect squares. So what we're going to do is first simplify the numerator and the denominator. In other words, we're going to simplify the fraction inside the radical. So 8 over 50 is going to become 4 over 25, and the x cube in the numerator will cancel with one of the x's in the denominator to give you just x squared. Now 4 is a perfect square, x squared is a perfect square, and 25 is also a perfect square. So we can, once we separate the radical to the numerator and the denominator, we get 2x over 5. Let's try the next one. Again, this is fairly simple because once you give the radical to the numerator and the denominator, you're going to get 12 over 3. But 12 over 3 is a whole number, so you make it 4. If it was an improper fraction, you can leave it. Or a fraction, you can leave it. Okay, here's another one. Try to simplify what is inside the radical first. Pause the video, see if you can do this. So here we have 36a in the numerator, which becomes, 36 divided by 4 becomes 9. And we have a squared in the denominator, and so it becomes 3 over a. Whenever you have a variable in the denominator, you have to tell the reader that a can be any number but 0. And that's why we write a is not equal to 0. And that's because 0 in the denominator makes the fraction undefined. Remember that. 0 in the denominator makes the fraction undefined. All right, here's another one, the last one for this set. So here we have 25, which is a perfect square, y cubed that can be broken up into a perfect square, and z squared, which is a perfect square. So what you do is you take out the 5 and then see what you can do with the variables. The y squared in the numerator is a perfect square and z squared is also a perfect square. So they're going to come out like so, and you're left with a radical y in the numerator. Okay, and here of course we want to specify that z cannot equal 0. So the next thing you need to know, and this is a very, very important item, how to rationalize the denominator. What to do when there is a radical in the denominator. Remember that radicals are irrational numbers and we cannot have irrational numbers in the denominator. Here we have radical 7 in the denominator, so we want to get rid of that. So one way to do it is to multiply the fraction by 1. When you multiply anything by 1, nothing changes. However, this allows us to manipulate the numbers so we no longer have a radical in the denominator. So instead of, I still have my radical 3 over 7, but instead of 1, I can put the same number in the numerator and the same number in the denominator, and I'm going to choose radical 7 over 7. And I'm going to choose that because when I multiply the denominators, it becomes radical 49, which simplifies to just 7. My numerator becomes radical 21. My denominator is radical 49, which becomes 7. With enough practice, you're going to get really quick at this and really fast. So let's see. Here we have radical 2 over 3. I need to get rid of my denominator. First I say, okay, I'm going to multiply by 1. But instead of the 1, I'm going to now multiply by radical 3 over 3, which makes my numerator radical 6 and my denominator becomes just 3. Here's another one. This one has a variable. Once we split the 2 into numerator denominator, we're going to multiply by 1. And now, can you guess what you have to multiply by? Radical 3 over 3. So the numerator now becomes radical 21x over radical 9, which is just 3. And this is called rationalizing the denominator, making sure that there is a rational number in the denominator. And if you solve this and you have a variable in the denominator, make sure that the denominator cannot equal 0. And that is it. Goodbye.